We're going to take a look at how to graph absolute value functions. We're going to start by graphing the parent function. And what a parent function is it's the most simplified version of a function, so it has no shifts or translations or anything like that. Well, in order to graph this function, I'm just going to go ahead and create a table of values. So I'm going to do my XY chart, and I'm going to pick some values for x. I'm going to do -3, -2, 0, 1, and 2. Now when I plug each one of these in for x, if I take the absolute value of -3, I'm going to get back a 3. If I plug in -2, I'm going to get back a 2. If I plug in a 0, I'm going to get 0. If I plug in a 1, I'm going to get 1. And if I plug in a 2, I'm going to get another 2. So now we need to come over here to our graph and we need to plot our points. Once you get your points plotted, you might be realizing that this probably doesn't look like any of the graphs you've done before. What's going to happen when we have an absolute value function is we are going to end up with a graph that has a resemblance to a V. And the reason for that is when we just have this plain parent function, absolute value, I can never get my y to be negative in this case, because anytime I take the absolute value of a number, it's going to return the positive because absolute value is your distance from 0. So we will not be down here when we have our parent function. Now we can shift our graph to get it down there, but that will be coming later. So our parent function looks like this. And now what that tells us is that any time we're having an absolute value function, it's going to have these characteristics. It's going to look like some version of a V. Now it doesn't mean it has to be this exact shape or size. It could be narrower, it could be upside down, but it's always going to have the characteristics of being a V. And that's what the idea behind a parent function is. All of the functions that will come from this will resemble the parent function. What we're going to do now is I'm going to show you some pictures from a graphing calculator of different equations that are graphed. So this first one right here is just the parent function, and you can see that right here it says that we have f of x is equal to the absolute value of x. Now, this next equation right here was f of x equals the negative absolute value of x. That is the graph down here that is a little bit darker. Notice what happened to it. It took the parent function and it flipped it upside down. And the only thing we changed was this negative sign. Now here's the next one. This time I graphed f of x is equal to 3 times the absolute value of x. Notice it's right side up again, and that would be because our 3 wasn't negative, but now the graph is much narrower, it's steeper than what our parent function is here. So think about that. The 3 made it steeper. Okay, the next one, I graphed f of x is equal to 0.3 times the absolute value of x. So 0.3 gave me this darker graph here, and that made it wider. Again, notice it's right side up though, and that's because the 0.3 wasn't negative. Alright, switching gears a little bit. Now on this darker one here, I graphed the absolute value of x plus 2, and notice what happened to my graph. It shifted it up 2 spots. So when I had the absolute value of x plus 2, it shifted it up 2 spots. On this one, I graphed the absolute value of x minus 2, and notice that it took my parent function and it slid it down 2 spots. Switching gears again, this time I'm putting the number inside the absolute values. So I've graphed the absolute value of x minus 2, and if you look at what it did to my parent function, it moved it to the right 2. And then the next one, when I do x plus 2, it moved it to the left 2 spots. So it took my parent function here and it slid it left 2 spots. So what we need to do now is we need to make some generalizations. So if I have an absolute value function, how can I look at it and know exactly how my parent function is going to be changed or moved? So what we're going to be working with now is this very generic function right here, very general, a times the absolute value of x minus h plus k. So this goes back to the ones we just looked at, and we're going to start with a. A does two things for us. The first thing it tells us is it's going to show us the direction that it opens. That was opening up or opening down, and that was determined by the sign. So if your a is positive, so if the number being multiplied by the absolute value is positive, it's going to open up. If the number being multiplied by the absolute value is negative, it's going to open down. And then the second thing that A showed us was the steepness, or how wide or how narrow it is. Now, the rule here is that if the absolute value of A is greater than 1, it's going to be narrow. So that would have been like having the 3. The reason we do the absolute value is because the positive or negative portion doesn't tell us steepness. That tells us the direction that it opens. So for steepness, we actually have to look at just the number portion of it, not the sign. So if the absolute value is bigger than 1, it's going to be narrower. If the absolute value of A is less than 1, it's going to be wider. And this is all compared to the parent function. Then the h is our horizontal shift. Now the h is the one that's inside the absolute value. And when it says it's in the opposite direction of the sign, if you look back to what we had right here, we had x minus 2. Now when most people see that, they're going to think of minus as moving to the left. Well, actually, it moved it to the right. Right here, it was an x plus 2. Most people would think of that as going to the right because it's positive, but it actually moves it to the left. So when we are doing our h, you have to take the opposite direction of the sign. And remember that h is the one that's always inside, right by the x. And then the last piece of this is our k. That's our vertical shift. That's how far up and down it gets moved. And for the vertical shift, you use the same direction as the sign. So if our vertical shift, if we have plus 3, you actually go up 3. You match the sign with what you would think it was. So here's a real quick example. If we had to tell how this compares to the parent function, we've got f of x is equal to 4 times the absolute value of x plus 7 minus 9. You would start by identifying piece by piece. The number being multiplied by your absolute value, that's our a, so 4 is a. The number inside by the x, that's our h. And the number out here is our k. So now we can use each piece to compare it to our parent function. F of x is equal to the absolute value of x. So compared to our parent function, what does the 4 tell us? Well, it tells us the two things, the direction it opens and the steepness. So we know that this particular one opens up because the 4 is positive, and since the absolute value of 4 is greater than 1, it's going to be narrow, or it's going to be steep. Then we can move on to the h. Now the 7 is our h. That tells us our horizontal shift, but we have to use the opposite direction. So this is a plus 7, which you would think is to the right, but you use the opposite for h, so you actually move 7 units left. Then the k is a negative 9. That tells us our vertical shift. We use the same direction as the sign, so the negative indicates down, so we would shift it down 9 spots. Now if you think about what that means, when I take my parent function, my vertex is usually a good point of reference. I always want to have my vertex on there. Now normally my vertex is at 0, 0. Well, if I were to apply just the two shifts, I would go 7 units to the left, and then I would go 9 units down, and that would end up being where my vertex would be. And then I would use the 4 from there. So these shifts can actually tell us the location of our vertex, because if I did this shift, instead of my vertex being at 0, 0 now, my vertex is now at negative 7, comma, negative 9. So our vertex is at the point h, comma, k. And always remember to use the opposite sign of your h. Okay, so here's a practice. Go ahead and pause the video and see what you can come up with these. I want you to describe the translation of g of x from f of x. So what I mean by that is I want to know, how do you get this function g from that function f? How would you have to move to get to g? So go ahead and pause the video and jot down what you think for these. On the first one, we were comparing it to the parent function, and so we had to look at the a, and that tells me that it opens up because it's positive, but it's also going to be narrower because the 2 is bigger than the 1 here. Also going to be moved right 5 because we do the opposite of what's in there, and then up 7 because we do the same. Second one, we're not comparing it to the parent function anymore. So for a, well, we have a negative compared to a positive, so this one's g of x is going to open down. But now as far as steepness goes, they're going to have the same steepness because the absolute value of 3 is the same as the absolute value of negative 3. So the steepness of those two does not change. And then to get g of x, I also included this minus 5, so that's a shift of down 5. Okay, and number 3 could have been pretty challenging. G of x is going to open up because a is positive. It's going to be wider than our f of x over here because we have a 1 there, and over here we have a 1/2, so it's a smaller number. Then we're going to move it left 9. You might be wondering where this 9 comes from. Well, my f function with this x minus 2 was shifted to the right 2 and then up 5, so this is like the vertex of my f function. Well, to get my g function, I need to be left of 0 7 spots, which is over here. So now as far as left and right goes, I have to move 9 spots to get from 2 to negative 7. And I have to move 9 spots to the left in order to get there because I'm starting at the 2 and I have to go to the negative 7. So it's actually left 9 spots. And then to get from a plus 5 to having a 0, I have to go down 5 in order to move from there to there. So it opens up, it's wider, it's left 9, and it is down 5.